All right, we have a question here dealing with logarithms. So, given that log BP equals x and log BQ equals y, express in terms of x and y log BPQ squared. All right, so here we see we need to use the product rule for logarithms. You can see two different variables attached to each other. And also, apart from the product rule, whenever you see an exponent, you also need to use the power rule. So let me bring the question here. Right, so we can see two variables attached to each other. So we apply the power rule. So this is going to equal to log BP plus log BQ squared. Now we're not yet done because yes, log BP, we can substitute it with which value? I think that was x. Yes, we can substitute it with x, but we can't substitute q squared with y. So now we need to apply the power rule. And this is the power rule. Log x a to the power n. So with the power rule, what you just need to do is the exponent, you bring it in front of the logarithm. So it becomes n log the board also it log. Okay. Colleagues, are we still about to see the board? Okay, okay, okay. Sorry, it paused for a while. So let me continue. Yes, you bring the I was explaining the power rule. So whenever there's an exponent, you bring it in front of the logarithm, as you can see here, n log x a. Right? This is the power rule. So we're going to apply the power rule here. We have log b q squared. These two, we bring it in front of the logarithm. So we're going to have log b p plus, so this 2 comes in front here. So you're going to say 2 log bq. So now we can express these logarithms in terms of x and y. According to the question, log bp equals x. Log bpq is y. So x plus 2y. That is our answer. Any questions? Hey, good evening. Good evening. Okay. As I'm explaining to you, colleagues who have listened, can you try this question here? It's on at the bottom here. Tell me what you get as I explain to this other one here. This, as I explain the question. So, sir, we are looking at question one for the assignment. All right. This one here. We need to express x and y in terms of this logarithm here. So, as I said earlier on, going to need to utilize two rules. The first one is the product rule. This one here, let me underline it. This is the product rule, all right? Whenever you see two variables attached, two different variables attached to each other, that should signal to you that you have to use the product rule. Are we okay with that, sir? Okay, then second, you also have to know the power rule. The power rule is whenever you or someone's trying to say something. Yes, the power rule, whenever you see an exponent in the logarithm, all right, what you do with the power rule is the exponent, you bring it in front of the logarithm. Okay. So with this question here, log b p q squared, we apply the product rule. So it breaks down to log bp plus log bq squared. Are we okay with this, sir? Are you? Yes. Right. We've broken it down and simplified it to this. Then we cannot easily substitute x and y yet because we've still got this q squared here. So we've seen since there's a power here, we need to apply the power rule. So as you can see, this power 2 comes in front of the logarithm. So it becomes 2 log b q. Okay. Then according to the question, now we can substitute. According to the question, log bp is equal to x and log bq is equal to y. So it's just a matter of substituting. Okay. Okay. Colleagues, have we all tried this one? What are we getting for this question here? It's similar to this one. Try it. Yes. Yes. Very correct. That is correct. I hope everyone is getting 2x plus y. Okay, that's wonderful. It's wonderful. Anybody else? Are we all getting 2x plus y? So applying the product rule, you break down the log like this: log b squared plus log bq. Then Here q we can easily substitute it with y, but x we need to apply the power rule. So the 2 comes this side, so it becomes 2 log bp, which we can substitute for 2x. Okay. Yes. Can we move on to the next rule, the quotient rule? Let me write down the quotient rule. This is rule number 3, which is called the quotient rule. Whenever you see division, have you seen here? We can see division here, log p over q cubed. So here we know that we're going to need to apply the quotient rule. And since we've seen there's a power here, we're also going to need to apply the power rule. Okay. So let me write down the quotient rule. The quotient rule is similar to the product rule. The only difference is this time instead of addition, it's subtraction. So log x a minus log x b equals log x over b. Or mute your mic, mute your mic, mute your mic, mute your mic. Is that Mr. Gilbert? Okay, he's the one who usually using two devices. Yes, so this is the okay. Next is the quotient rule. All right. So as you can see here, log xa minus log xb equals log xa over b. So in our question here, we have log b p over q cubed. So applying the quotient rule, we say log b p minus log b q cubed. All right. Log b p minus log b q cubed. All right. So here we can substitute log bp with x, but log b cubed, we have to apply the power rule, where we're going to have to bring the exponent in front. So this q to the power 3, this 3 comes in front, so it's 3 log b q. And then we can substitute. So log bp according to the question is what? Let's see, log bp was x if I'm not mistaken. Yes, log bp is x, log bq is y. So we say x minus 3y. Any questions? If there are no questions, colleagues, here's one to try. That is correct. Now you're even able to solve by just looking, right? 2x minus 3y. That is correct. Are we all getting that? Yes. Mhm. The log b, there's nothing you need. When finding the final answer, there's nothing you need to do with it. You just substitute. Yes. If it's log, once you have a log bp, that is an x. A log bq, that is a y. So it's just a matter of first you simplify the expression so that you can easily substitute x and y. Okay, that's the whole concept here. You want to simplify the expression so that you can easily substitute. And a lot of mathematical questions can be brought in this format. So, yes. Um, or question two is we were using the quotient rule. Your question is related to this one, right? This one here. Yes. So here, when you see there's a division between variables, you know you need to apply the quotient rule. Okay. So the quotient rule, log x a minus log x b equals log x a over b. So when you see two variables being divided, as you saw in this case, you make it here we had log p over q cubed. We made it log b p minus log b q cubed. So yeah. So it's just a matter of remembering these laws. These laws, unfortunately, they won't be given to you in the exam, so you must remember it. Maybe your next question is, how do I remember these laws? Is that the next question? How do I remember these laws? The way you remember them is by practice. So are we all getting 2x minus 3y here? Are we all getting is it 3x minus maybe 2x minus 3y for this one here? We can move on to the next part of the question. Are we all okay with the quotient rule? I'll assume that is a yes then. Okay, we've got now the third question here. We've got log b and over the square root of bp squared over q. Network is really misbehaving today. Yes, I was asking, we can proceed to the next part? Are we okay with the quotient rule? Okay. Okay. So we've got this one, log b, the square root of b, p squared over q. So here there are some other rules that we need to be aware of so that we can simplify this expression. The first rule that comes from surds, okay, the topic of surds. This rule, it states that the square root of a times the square root of b equals the square root of ab. So why are we using this rule? Because first we want to separate the p from the q, all right? Because remember, in order to substitute at the end, we need to be able to have a log bp and a log bq. So the first thing, we need to separate this p squared. So this becomes log b, the square root of b over q multiplied by the square root of p squared. Colleagues, are we okay with this? Right. So the square root of p squared is p, right? So I can say log p, the square root of b over q multiplied by p. So we got the square root. The next thing that we need to do is, at least for p, we got rid of the radical, all right, because we got the square root. So here, in order to get rid of the radical, you have to remember this law from indices: a to the power m over n equals the root of n, a to the power m. So if you want to get rid of a radical, okay, you have to convert it into an exponent, a fractional exponent, an exponent that is a fraction basically. So it becomes now log b b over q to the power half multiplied by p. Are we okay with this part? Remember, this one we need to go step by step. Uh-huh. Write this down here. Have you seen here? What I'm doing here first is I'm trying to simplify and break down the expression. Have you written down this rule of thirds? Oh, yes, madam, you have a point there. All right. So the first thing that we need to do is we need to separate the variables. Oops. Need to separate the variables. So here, since we've got this bp squared over q under one umbrella, first we separate this p squared. All right. Using this rule here, we separate the p squared. Okay. Have you seen? It becomes log b square root of b over q multiplied by the square root of p squared. Are we okay with that, madam? First, we separate the variables. Are we okay with that, Madam Juliet, before we go to the next part? Okay. So, the square root of p squared is p. All right, Madam? The square root of p squared is p. So at least, because here, all in all, first things first, want to get rid of this radical. Okay, that's the first thing we want to do. Want to get rid of the radical completely. All right, so we've partially got rid of it on the p side. All right, we've still got a radical here, but we're going to deal with it in the next step. But first here, we've got rid of the radical that's attached to p squared. We've got the square root of p squared, and that is p. Then, to get rid of this remaining radical, all right, as I said, this law here from indices will help you get rid of the square root. All right. For example, a to the power 1 over 2, yes, is the same as the square root of a to the power 1. Yes? Is that a question? Yes. So the way I've got rid of this radical here was using this law here for indices. Okay. Okay. Yes. So to get rid of this remaining radical, using this law, we change this radical to the power 1 over 2. Okay. Using this law here from indices, we get rid of this radical by changing it to 1 to the power 1 over 2. Are we okay with that part? Are there any questions on that part? Madam Juliet, Madam Christine, Madam Miriam, Madam, okay, Mr. Oh, yes, yes, this dot, yeah, a dot means multiplication. Or sometimes you can just leave it like this. Okay, so the dot can mean multiplication. Yes. So here, first what we can do is we can first apply the power rule, all right, because we've got two terms attached to each other, b over q to the power half and p. So we can first apply the power rule, I mean the product rule. So that becomes log b b over q to the power half plus log bp. Are we okay with this? Any questions? Remember, we have to move at a slow pace so that everyone understands. Mm-hmm. Mm-hmm. You can still say maintain the same multiplication. You can still leave it like this. You can put a dot, or you can just leave it. How can I say? where they looked attached to each other. So you will still we will still maintain that symbol. And that symbol is what's going to allow us to apply firstly the product rule. I'm saying this symbol here, this multiplication symbol, enables us to apply the product rule. So here, at least we've got our log BP, which we can easily substitute with, is it X? But now we have to get our log BQ. All right. So here again, have you seen we've got B over Q to the power half. So what is this telling us? This is we can use the power rule first. So first thing, this power half, we take it this side. So it becomes half log B B over Q plus log B P. Are we okay with this, colleagues, before we move further? Okay. So now what is remaining is we can apply the quotient rule for this here. So we're going to say half, open brackets, we apply the quotient rule, log B B minus log B Q plus log B P. Colleagues, are we okay with this? Remember, as I do one step, I ask, are we okay? Then I do another step, are we okay? Until we reach the final part. Any questions or queries? Now, with logarithms, anytime you see the base is similar to the value, okay, like here log xx, you always get a 1. Okay. For example, if you have to see log 5, 5, it equals 1. Why? Because if you say 5 to the power 1, that's going to give you 5. Okay, if you say this base here, this 5 to the power 1, it's going to give you 5. So anytime you see the base is the same as the value, you are going to get a 1. So in this case, log B, it's a 1. All right, so I'm going to say half this log B, that becomes a 1. Log BQ, that is Y, plus log BP, that is X. If you want, you can distribute the half times 1, that is half times negative Y, negative half Y. Yes? No, because the question has told you, the question has clearly told you here that log BP is x and log bq is y. So if you do that, you are going to get wrong, your answer wrong. Okay. So maybe let's just go through the steps again so that we fully digest what has happened here. All right. First things first, we need to get rid of the radical or the root. All right. We need to get rid of it. And also, we need to separate the variables. So, according to the law of surds, square root of a times square root of b equals the square root of a times b. So even here, log b square root of bq equals square root of b over q multiplied by the square root of p squared. Because when you multiply these two radicals, you come back to this original expression. And the next thing we need to do is we need to get rid of the radicals on each term, or each of the variables. So the square root of p squared is p. Or if you wanted to do it like this, you'd have said p squared times half, and then half times 2, that is 1. You can do that, or you just say the square root of p squared is p. Okay, two ways to do it. So we've got rid of the root for p. Next, we need to get rid of the root for b over q. All right. And as I said, this law of indices, a to the power 1 over 2 is equal to the square root of a to the power 1. So that's why this radical became the power half. Okay. Even for p, if as I said, this radical, you can put it to the power half and then you multiply 2 times half, you get 1. So that I just got rid of it because we're just getting the square root. All right. So this square root becomes to the power half. So now since we've got two distinct terms attached to each other, b over q to the power half multiplied by p, we can first apply the product rule. So when we apply the product rule, it becomes log b over q to the power half plus log bp. So first we've applied the product rule. Next, after that, since we see log b over q has got an exponent attached to it, we can apply the power rule so that we get rid of the exponent. As you saw, that's how the half comes in front. Yes. Then you would have applied the quotient rule after the product rule. After you apply the product rule, and since there's no this power half, then you also apply the quotient rule. Yes. So once you've brought the half in front, now you have half log b over q plus log bp. For log bp, we're already set with it. We can already substitute it. What we're working on is just this log b over q. So since we can say b over q, we need to apply the quotient rule. That's how you've seen in these brackets here, I've put the quotient rule. So you're going to have log bb minus log bq, close brackets, plus log bp. Then, whenever the base is same as the value or the number that is there, as I give an example, log 5, you're always going to get a 1. I just forgotten the name of this row, but yeah, you're always going to get a 1. So here you can see the base b and we've got your value b. So this is going to turn into 1. Then the log BQ, we substitute it with y. Then log BP, substitute it with x. And this is how we get our value. Half, open brackets 1 minus half, open brackets 1 minus y plus x. This is an easy answer to remember. So in the exam, you see this question, just remember that answer so that whatever, when your workings give you something different, you know yourself that you are wrong. Right? Yes. So any questions before I give one for you to try and we close off the class? Plus x. Yes, 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 yes. Yes. If you want, you can expand. You say half times 1, half. Half times negative y, negative half y plus x. Either way, you will still be marked correct. And as professor changed the rules because he said usually when you're solving his questions, you must even be explaining as you are solving. Did he say he's still maintaining that? Find out. Yeah, find out because there are those there are those lecturers who can see that as you are solving, you're also explaining what you're doing while you're solving. Yes. So let me just give the final question, then we call it a night. It's the same format. You have log square root of b p over q cubed. Can we try this one here? Whenever you don't see a base, assume base 10. I think we will need to maintain the p squared because once you do that separation thing, it's going to be complicated if this p is just the square root of p like that. So yes. So log b square root of b p squared divided by q cubed. Oh, you're not able to see the board? It's log b square root. Yes. You're not able to see the board? Is everyone else able to see the board? Yes. So log b square root of b p squared over q cubed. So first things first, you want to get rid of the radical. First, you want also separate B and P and Q and get rid of the radicals. So just follow the same steps. Now I need to transfer to the second years. Colleagues, maybe when you're done, what you just do is send me a screenshot. Okay, just send me a screenshot. I'll tell you correct or wrong. Correct or wrong. Is that okay? Is that okay? I'm saying that I need to transfer to the